Now, I just want to quickly go into what is deep learning because this webinar is based on deep learning, right? So artificial intelligence is the one which is a whole very big domain by itself, where if a machine mimics anything, something similar to your human behavior, that is your artificial intelligence, right? It can be anything like a robot is replicating or replacing your waiters maybe. Okay, so that's artificial intelligence. Okay, anything which mimics your human behavior, that's an artificial intelligence. And machine learning, which we have already looked into, where we are trying to improve the experience, okay, where we are trying to improve the machines with experience using some statistical methods. Okay, what does that mean? We are trying to, let's say that I have a lot of data, I'm building a machine learning algorithm on the top of those data using some mathematics or statistics, okay, such that this machine learning is basically trying to predict the future. Now what is this machine learning? It's just an algorithm, okay, which needs a lot of historical or past data, and then using mathematics we'll try to identify the patterns between inputs or maybe between inputs and outputs. Okay, so that's something similar to, you can think that as a machine learning. Now deep learning is basically, it's a multi-layer machine learning, I would say, or it's a basically multi-layer neural network. Okay, so I know that this quite, the definition what I've written might be slightly tricky here, but I will try to explain deep learning in the next slide with a better explanation. But before that, let's try to think why we need deep learning and when to use deep learning. So if you have already attended the machine learning courses in the past, which I've already delivered, you must have seen the data sets what I have used. It requires numerical data set. Numerical data set in the sense structured data set. Okay, you are working with mathematical data or number data, okay, or maybe discrete or categorical data most of the times, which can be converted into numbers. But when it comes to unstructured data, images, how do you think in Facebook, whenever you like put a picture of yourself, Facebook will tag the person by itself. If you remember 5 years back, we used to tag a person, like let's say that I'm taking a picture with one of my friends and I'm just uploading that on Facebook, right? We used to tag that person, right? We used to tag our friend in our images, in the pictures. But now if you remember, if I just do the same thing now, Facebook will tag my friend by itself. How is that possible? How is Facebook able to predict that this person is basically my friend X or Y, maybe something else? Okay, because in the past we might have uploaded a lot of images, okay, of that person. Maybe we have uploaded, or maybe someone else might have uploaded a lot of images of that person. Okay, so images is one kind of unstructured data. Text, for text is also, let's say that you have gone for a movie, right? And you're giving the review for that movie. Maybe I have liked that movie, but maybe the end part of that movie was not that good. Do you think if the person who is actually looking at the reviews, does that person look at those, will read all the review? Maybe not really. You must have seen that the review of the movies, right? 3.5 star out of 5, 4 star out of 5. How would they come to know with that? Maybe based on the star rating of a person who is giving for that complete movie, right? But if a person is writing a complete text review of 10 lines or maybe 5 lines, will someone be reading that review? We just need to figure out whether that review is a positive or negative review about that particular movie. So for that, we need machine learning on the text, right? Which is again unstructured data. Similarly, speech recognition, video analytics. That's where, when we have unstructured data, that's where we need deep learning. Okay. And when we do apply deep learning, so if you notice here, machine learning will perform quite good when you have less amount of data. Okay, and if you look at the less amount of data, your deep learning algorithms are not performing that good till, let's say, at this point of time. Your machine learning algorithms are performing, which is red color line performance. Red color line is performing better in comparison to all 4 lines, right? But as the data increases, you will notice machine learning will become stagnant in terms of performance. But deep learning performance will keep increasing. So basically for deep learning, you require more and more data. Okay. So when you have a lot of data, maybe in millions or billions, you can always go for deep learning. And when you have unstructured data, you should ideally go with deep learning. Okay, that's one thing which I wanted to clear here. And now coming to what is basically a deep learning, I'll just try to give an example with respect to this image or with this slide. Okay, now let's say that if you remember from the first course, we have looked into logistic regression, right? Let's say that I have some inputs, and then based on certain inputs, I'm just trying to classify something. Okay, let's say that I have credit score, person's income, or maybe like how much expenses that person has, and based on that I need to identify whether that person will fall under defaulter or not defaulter list. So we have inputs, we are just trying to predict whether the person will fall under defaulter or non-defaulter list, right? So that's a very simple logistic regression which I'm building. I have inputs, I'll just pass those inputs, right, and then I'll come up with the output, yes or no kind of thing. Okay. In deep learning, basically, when you have inputs, you will not directly jump to your output. You will have intermittent layers here. So basically think in this way. Let's say that you're looking at an image of cat. How would you know that that's an image of cat? First it will go to your eyes, and then it will pass through your brain, and then in the brain you might have a lot of multiple layers by which you will get a signal that's an image of cat, right? That's how you will tell that the image of a cat is basically a cat, right? So what I'm trying to tell here is, instead of having no layers in between in your machine learning algorithms, in deep learning algorithms, you will have intermittent layers. Okay. Now, in machine learning, the computational time will be very less because you don't have intermittent layers here. But in deep learning, you will have lot many intermittent layers, and that's why you will have more opportunity to come up with the better results for your output. Or maybe you can train your model in quite effective way when it comes to deep learning, because you have intermittent layer here, right? You have some input, maybe images of cats and dogs. You need to predict whether that image is of cat or dog. So first it will go through some layer, and then it will come up with some more outputs. Those outputs will go on to as an input for another layer, and for that output will be going here. The output of this layer will be coming as a final output for us. Okay, so I know it will be slightly difficult to understand at this point of time, but just imagine that it's basically performing a multi-layer. All the inputs are basically passing through your multi-layer brain at the back end. So, and that's a reason deep learning are more efficient in terms of replicating your brain in comparison with machine learning. Okay. Now, deep learning is basically when you have multi-layers, right? And most of the times deep learning are actually built with neural network as a machine learning algorithm or as a base algorithm. Okay. And neural network can be divided into three different types: artificial neural network, convolutional neural network, and recurrent neural network. Okay. Artificial neural network is the one which I've shown just now in this example. Okay. So on the left side, you can imagine that's a machine learning algorithm. Right side, you can imagine that's a deep learning algorithm. Okay. Now, most of the times you will notice that artificial neural network is used for the numerical data set. It can of course be used for images as well, but it might not be as effective as your convolutional neural network is. Okay. So I will not go into that detail of what is ANN, what is CNN, RNN, but I'll just tell you basically ANN is used most of the time when we have numerical data set, and CNN is used when you have images, convolutional neural network, which is basically more of RGB, because on the images we always have this RGB, right? Red, green, blue. And then for the text, recurrent neural network is the one which is very important, because in the text, if you notice, we need sequence, right? In my sentence, I'm talking something. Let's say I am talking something. So talking is coming after I am. Something is coming after talking, right? So there is a sequence of the words which I'm while talking, right? And that's where recurrent neural network can handle that kind of sequences. And that's the reason recurrent neural network is most effective when it comes to text to data, or maybe speech or something. Okay. So this is the basic intuition which I wanted to give. If you have intermittent layers, that's basically a deep learning algorithm. Okay. So what you are seeing here is a logistic regression, very simple logistic regression. And if I'm just putting intermittent layers here, that will become your deep learning layer. And you will know how it has become a deep learning layer and why I'm calling deep learning or the equations. What when you look into your third course, when we go in depth of mathematics of this third course, you will notice that all the equations what we go through in this deep learning course will basically an extension of your logistic regression. Okay. So we'll look into that in third course in very detail, in depth with a lot of mathematics. By that, everything will be cleared. But for now, what we can understand is basically a deep learning is something which is a multi-layer of machine learning. Like if you have intermittent layers between your inputs and output, that's basically a deep learning. Okay. And we always use neural networks at the backend as an algorithm. Okay. So if I want to look at the case studies, let's say the very famous case study here is, if I want to take an example, very famous case study would be spam filter. Okay. If you imagine in 20 years back or maybe 15 years back, you might have got a lot of spam emails in your inbox, right? You must have got a lot of spam emails in your inbox. But now if you notice in the current time, you must have got very less spam emails in your inbox. What is the reason? Because in the past, we might have looked into all the historical data, and based on that historical data, we have identified what emails can be spam, what emails can be non-spam. And now whenever there is a new email income, like whenever there is a new email coming to our inbox, the backend algorithm predicts whether it's an spam or non-spam. And based on that, it will filter those emails. So this kind of case study will be there in your third course and will not be directly jumping into this. There will be a mathematics. We'll try to convert this text into numerical data set, and then we'll apply, as this is a text data set, we should apply recurrent neural network here. We'll see all those mathematics in the third course. But if I want to just talk in layman terms, subject, let's say you have a subject, great news, hello, welcome to this so and so. And by looking at this subject, you can identify whether this subject should go under spam or non-spam, right? And let's say this subject, because this is a smaller one, let me read this. Statistician position open, feel free to circulate this to get a statistician for us. Thanks, Krishna. This seems to be a non-spam email. Okay. And then maybe this is a third subject. I'm just giving you some examples with respect to spam filter. Based on the subject, we try to predict, or based on the subject or description. Here I'm just taking an example of subject, but you can also take the description as well, body of the email. Based on that, we try to figure out whether that email is spam or non-spam. And maybe if I just want to take an example of mechanical, let's say lathe machine review. We have bought a lot of lathe machines, right? In our college days, our university must have bought a lot of lathe machines. And as a student, we must have worked on those lathe machine. Let's say there is a new university which have bought lot many lathe machines for their student. One of the students, or maybe like if someone is giving the review for the lathe machine, let's say that the first review is, I'm happy to buy this product as it has reduced the manual effort. So they should have not been dot here. Okay. The review should be, I'm happy to buy this product as it has reduced the manual effort. So basically you can understand that by looking at this review, you can identify what is the sentiment of a person, right? Whether the person is happy, neutral, or he's angry or sad, something like that. So the first review is basically telling us that person is happy. Okay. Second review, disappointment after buying this product. It clearly tells that it's a negative expression, the negative review. Third review, machine is working as expected, but the price is very high. So maybe that review comes under neutral. This one, I bought this for my university, but some of the machines are defective. Okay. So maybe negative, or maybe like sad smiley or sad sentiment. But do you think that lathe machine reviewer or the person who is actually manufacturing that lathe machine will have a time to read all these reviews? Maybe yes, but most of the times no. So what we can do for that is, in the past, or maybe by looking all the historical data, we could have come up with a deep learning model or machine learning model it should be basically deep learning because we are handling text data. But you can also use machine learning. But how? We'll see that in the third course. But let's, for time being, let's imagine that we are using deep learning. Remember that for deep learning, we always use neural networks. Okay. So let's say I'm using neural networks. I'm just converting this text into numerical data set. I'm just based on the historical data, we already have the label. Let's say for this, the label is happy. For this, the label is, let's say, sad. For this, the label is neutral, and so on. So you will have lot many reviews and you will have some labels, right? Someone might have done manually labeling for that, let's say. Now, once we have the labeling, we'll build a machine learning algorithm on that, deep learning algorithm on that. And then whenever there is a new review, we'll try to predict what will be the label for that, what is the output for that, whether the person is happy, neutral, or sad. Okay, we'll just input that complete review. Okay, just imagine that person is writing a review of, let's say, 8 or 9 lines. We'll just incorporate that into our model, and our model will predict whether the person is happy, sad, or neutral. Okay, rather than we are sitting and reading each word by word and identifying whether the person is happy or not. One more example where we can use convolutional neural network. I'm just trying to look, let's say I have a data set of cars and cycles. I want to predict whether the image is of car or bicycle. So maybe we have a lot of historical images. Based on that, we have labeled whether this is a car or bicycle. Now, once we have built our deep learning model on the historical data set, whenever there is something new image coming in, rather than me looking at that image and telling and writing or manually labeling it as whether it's a car or bicycle, I'll incorporate that image to my machine learning model, machine learning or deep learning maybe. I'll just incorporate that in my CNN model, which is convolutional neural network, which is a type of deep learning. And then it will tell me that image is basically a car or bicycle. So what we are trying to do here is we are trying to do the prediction. We are trying to reduce all the manual effort. Okay. So the examples what I have taken here is basically all the supervised learning. Okay, because we have inputs and output here. See this spam or non-spam, you will have the label, right? Whether that subject is spam or non-spam. So when you have your output, we call that as, or let's say here, happy, neutral, or sad. So this kind of analysis is basically called as sentimental analysis because we are trying to predict the sentiments. Okay. Next thing is here also we are trying to predict whether the image is car or bicycle. So we have the outputs here, and that's the reason I'm calling this as supervised learning. Now in this supervised learning, you can use your machine learning algorithms, or maybe you can use neural networks. When you use neural networks, lot many layers, intermittent layers, then it is called as deep learning. Okay. So this is all which I wanted to discuss in this webinar. Thank you very much